How is titanium made? Have you ever wondered how the metal inside airplanes, spacecraft, medical implants, and even sports equipment is actually made? That metal is titanium. One of the most remarkable materials on Earth. It's light, incredibly strong, resistant to rust, and can even survive in seawater and outer space. But titanium doesn't come ready-made. It starts deep inside the Earth, hidden inside ordinary-looking rocks. And it takes an extraordinary process to transform it into the shiny, powerful metal we rely on today. So, let's explore the fascinating journey. How titanium is made. Titanium is a chemical element, number 22 on the periodic table. It was first discovered in 1791 in England by a clergyman and amateur geologist named William Gregor. He found it inside black sand called ilmenite. Later, scientists realized this mysterious element had unique qualities. It's as strong as steel, but nearly 45% lighter. It doesn't rust, even when exposed to water or air, and it's non-toxic, which means it can be used safely inside the human body. But there's a catch. Titanium is never found pure in nature. Instead, it's locked inside mineral ores like ilmenite and rutile. Extracting pure titanium from these ores is one of the most complex processes in modern metallurgy. The journey of titanium begins with mining. Most titanium comes from sand and rock deposits rich in rutile and ilmenite. These can be found in countries like Australia, South Africa, Canada, and India. Miners collect these heavy mineral sands, often using dredges or open-pit mining. The sand is then separated by density and magnetism to concentrate the titanium-rich minerals. What's left is a black, grainy concentrate that contains about 90% titanium dioxide. Still not metal, but the essential raw material for the next steps. Once the ore is collected, it's processed to remove impurities. The most common method is to convert the ore into titanium dioxide, a white powder that you might know as the pigment in paints, plastics, and even sunscreen. But for metal production, this titanium dioxide undergoes a different path. It has to be reduced, meaning scientists need to strip away the oxygen atoms that cling tightly to titanium. And that's where one of the most important methods comes in, the Kroll process. The Kroll process, developed in the 1940s, is still the primary way titanium metal is made today. Here's how it works. First, the titanium dioxide is combined with chlorine gas and carbon at high temperatures. This reaction produces a liquid called titanium tetrachloride, or TiCl for short. It's a clear, volatile liquid, but still not pure titanium. Next, the titanium tetrachloride is placed in a sealed reactor. Inside, it's heated to around 1000 degrees Celsius and mixed with magnesium metal. The magnesium acts like a thief. It grabs the chlorine atoms and leaves behind spongy titanium metal. This sponge-like titanium is porous and brittle, but it's pure. The leftover magnesium and magnesium chloride are recycled, and what remains is the raw form of titanium metal. The titanium sponge is then crushed, pressed, and melted. It's usually melted in a special vacuum furnace, sometimes multiple times to remove any remaining impurities. This creates large, shiny ingots, solid blocks of pure titanium metal. From these ingots, titanium can be forged into sheets, rods, wires, or powders, depending on its final use. Sometimes it's also mixed with other metals like aluminum or vanadium to form titanium alloys, which are even stronger and more versatile. So, where does all this titanium go? Aerospace, airplanes, spacecraft, and jet engines rely on titanium because it's both strong and lightweight. Medical field. Titanium is used for artificial joints, dental implants, and surgical tools, since the human body doesn't reject it. Everyday life. You'll find titanium in bicycles, watches, eyeglass frames, and even sports equipment. Marine industry. Ships and submarines use it because it resists corrosion in seawater. And here's a fun fact. Some artists and jewelry makers love titanium too, because it can be heated to produce brilliant rainbow colors without paint or dye. While titanium is an amazing metal, producing it is expensive and energy-intensive. The Kroll process requires high heat, lots of electricity, and generates waste. That's why scientists today are researching cleaner, cheaper methods, like the FFC Cambridge process, which may someday replace the Kroll process. So now you know, titanium isn't just dug up and used. It takes mining, chemistry, high-temperature reactions, and careful refining to create the strong, silvery metal we see in planes, medical implants, and everyday tools. Titanium is truly a modern wonder, hidden in simple rocks, transformed by science and used to build the future.